Hi everyone, I hope you're doing great. First I'd like to start by saying thank you to Kiwi for inviting me to speak at this conference. My name is Leandro Mazzuquini and today I'm going to talk about why React Native teams need native developers. So this talk is completely based on my experience and the things I've learned while working at Skyscanner, and I will try to show you, I'll try to give you some examples of why I think it's important to have some native expertise in React Native teams or React Native projects. So let's get started. First, a little bit about myself. I'm originally from Argentina, although I also have some Italian roots, so that's why you'll see me speaking a lot with my hands. Like about 1.5 years ago, I moved all the way from Argentina to London to join Skyscanner. Now, in case you don't know, Skyscanner is this app which you can book flights, hotels, and you can also do car hire. So if you don't know it, check it out. And yeah, as I was saying, I joined Skyscanner, and since I joined, I've been working in the React Native enablement team. So in this team, we take care of the React Native infrastructure, and we try to provide our React Native developers with all the set of tooling and support that they need to create features. And now, without being said, an interesting thing about me is that I am actually not a React Native developer. I have no experience in React Native development, or before joining Skyscanner. I've been making Android apps for more than 8 years, so my whole experience was as a native Android developer. So you may be wondering, what is this guy doing in the React Native infrastructure team? Guy who has no experience with React Native. And let me tell you that I asked myself the same question on my first day at Skyscanner. I will never forget that first day when my manager told me, you're gonna be working in the React Native enablement team. I wasn't expecting that at all. It was really weird to me. I'm pretty sure my face must have looked something like this. So I was really worried, I was really concerned at the moment that I wasn't going to be able to make any valuable contributions in a React Native team with only native background. But luckily for me and for everyone in the team, I was wrong, and as it turns out, there's a lot of work that needs to be done on the native side. So now, this is what this talk is all about. I will try to share some examples of this native work for React Native. But before jumping into the examples, let me just quickly check by show of hands. How many of you have worked or just play around with React Native here? Okay, that's another big number. So that's good, because now we're going to talk about what React Native actually is. So React Native is a framework for building mobile apps using only JavaScript and React. And I say only in quotation marks because, as we'll see, that's not always the case. Sometimes we need to write native code. And then one of the main selling points is that a React Native app is a real mobile app. And what they mean by this is everything that we see rendered in the screen, everything that the user interacts with, is a native view. So there's no web or HTML render content, it's all native. So to understand how they do this, let's have a quick look at the React Native architecture. So we have a client side that it's written in JavaScript, and this is what usually the developers in React Native use to create features. They just write code in JavaScript. Then we have the core and bridge part, which is mostly written in C++. We also have some objective C++ code, which is used to communicate with the iOS native side. And we have Java code, which is used to communicate with the Android native side. And then we have the native side. And this is where the actual implementation for everything is. So pretty much everything that happens in in our React Native app has a native implementation underneath. So there's no magic here, and this is how they achieve this feature, mobile native app feature that they sell. And because I'm an Android developer, for this talk I'm going to focus on the Android side. So I'm going to show you now the first example, which is React Native performance metrics. So if we want to have the best performance, first we need to know how good or bad our app is performing. So we need to have some performance metrics. I'm talking about metrics like React Native startup time. So React Native has an initialization process. And in order to display any screen in our app that is written in React Native, we first need to complete that initialization process. So we are interested in knowing how long it takes to initialize React Native. And in our metrics, it looks something like this. This is just a trend line of the React Native startup time across our different app releases. And you can see that it's been dropping mainly because of some performance improvements that we did, and also because Facebook has done some really good performance improvements. So for example, the latest one, Facebook released a new JavaScript engine for Android, and that improved the performance. We adopted that and improved the performance quite a lot. Another example of metrics is native module setup time. I'm going to talk about native modules in detail, but for now, let's just say that native modules are a way of accessing native code from the JavaScript side. And all of these native modules need to be set up first, before we can actually use them. And the thing is that for some of them, we need to complete the setup during the React Native initialization. So that means that if a module setup is too slow and we are doing it in the React Native initialization, then it can affect our React Native startup and it can degrade it, it can make it slower. So we want to know how long it takes to set up each module. And it looks like this. So this is just a list of some of our native modules, and we can see how long it takes to initialize each one of them. And in here we can see that, for example, localization takes a long time, and this is telling us that we should probably work on improving the performance of that one. And then a few more examples of metrics. We have startup delta time. This is our most important metric, and it's defined by the relationship between the native startup process and the React Native startup process. So it's the difference between when the native startup process finishes and when the React Native startup process finishes. Don't worry if it doesn't make any sense now or it sounds really hard, because I'm going to talk about this specific one in detail later on. But just for now, keep in mind that it's our most important one. Then we have screen render time. This is easiest, how long it takes to render every React Native screen. And then we can do all sorts of queries like startup time by OS version, startup time by device. We had a dashboard full of these metrics. And the reason why I am mentioning all of these metrics is because all of them are implemented on the native side. There's no JavaScript code involved in here. So I'm going to show you now some code. How many Android developers we have here? Cool, because this is all Java and Kotlin code. I'm going to try to explain it in a way that you understand the concept. But let's start with this one, which is part of the React Native core, as you can tell by the package name on the top. So in here, what we have is a set of constants for every part of the React Native initialization process. So you see we have tons of them. It's a huge list. And the thing is that for every part of the process, we have a start and an end constant. So basically, by taking React Native, what it does is it it fires an event with one of these constants, and by taking the start and the end for every stage, we can just calculate how long it takes to complete each of the stages of the initialization. And the way we use this is with this class, which is also part of React Native Core. And we have here a list of listeners that implement this marker listener interface. This is just an interface with only one method that receives one of the constants that we saw before. And basically, we need to call this add listener function, and React Native will start sending us events about the initialization. And similarly, we can call remove to stop, to unsubscribe. So this is all React Native code, or React Native core code. Now let's see our side. We are going to jump to Skyscanner's code. And this is how we implemented the performance metrics. This is a Kotlin class, and because we are using Kotlin, we can use type Alias. So type Alias here, we are using it to redefine or to create a type called React Marker Listeners function, which is basically a function that receives a marker listener and returns unit, which in Kotlin means void. It's just a void method. So if you take a look at these that we saw before, they are exactly that. They are functions that receive marker listener and they are void functions. They basically don't return anything. So the reason we are doing that is because we want to be able to do this. We want to inject mock functions for testing. So in this case, we default add React Marker Listener and remove React Marker Listener to the two functions that we saw before, but then in testing, we can pass mock implementations on all of that, and then in this case, we can make sure that we don't use static method calls inside our code. So the first thing that we need to do is we call this init function, and we subscribe. We start receiving the events from React Native, and to this subscribe we pass this marker listener implementation that we have now in. And this is just delegating the call to handle React Native event function that we have down below. So in this function, we are using this when structure. Basically, we are using it as a filter. So of all the events that happen during the initialization, we are interested in a few of them, not all of them. So we are using the when to filter out. So we say we want to know when get React Instant Manager start or Ranches bundle start. These are just different events of the initialization. And for each one of them, what we are doing is we are using this current time function, and we are saving the time in some data structure that we have internally. So basically, we are saving the time when each one of these events happened. That's all what we are doing here. And then in this event, we know that this is the very last event of the initialization. So in here is where we unsubscribe, where we say, okay, we want to stop listening for events. And for those of you who are Android developers, you might recognize this, which is Alias Java. So why are we using Alias Java for here? If we go back to this init function, I skipped the first line, which is subscribe upstart. And this is a function that we have defined here. What we are doing, we are calling app launch monitor dot observe app launch event. So this app launch monitor is a class that we have implemented in our native side, and is sending us events of the native startup process. And we are filtering. We want to know when page started happened. And why is this important for us? Because when that happens, it means that the splash screen disappears, and we are showing the first native screen of our app. So when that happens, we do the same thing. We take the time when this event occurred, and then we use, again, our Java to synchronize when the native startup process finished and when the React Native startup process finished. And this is related to what I told you about before, the startup delta time. We want to know when both processes finish to calculate the time difference between these two. And when we gathered all the metrics, all that we do is just call this function that will load all the metrics to our analytics platforms. So this is it. This is all the implementation, and as you can see, there's all Kotlin, there's all native, there's not a single line of JavaScript here. And it requires that you basically, to understand this, we had to go in the Facebook code base and understand their native code. So basically you need some native expertise to come up with these metrics. So that's great. Now we have our performance metrics. We're great to actually start doing something with that. We're great to start doing some React Native performance improvements. So we've done quite a few, but for this talk, I want to focus on one that has been done on the Android native side, and that improved really, we got a massive improvement with this one. But before that, let me explain to you how our initialization process works and how React Native fits in this process. So let's forget for now about React Native. Let's just assume that we have a native app, normal native app, and this is what happens when we start the app. We just display the splash screen, we do our native initialization stuff, and when that finishes, we show the first native screen. And this is all good, this is just normal native app. Now let's see what happens when we add React Native into the mix. Now we have this. Now we have two parallel processes, and you can see that even though they are parallel, they don't start at the same time. So why is that? I told you before that we are using something native modules, and that these native modules, the thing is that in our case, those native modules are using native code. And they are using native components. So for example, let's say we have a native module for our localization system. And that localization system lies on the native side. So we first need to initialize the localization system on the native side to be able to initialize these native modules. And these native modules are started during that React Native startup process. So basically we have a dependency, because our native components are initializing here, and then we need to initialize our native modules there, but they depend on this one. So we can't start that at the same time as that. We first need to finish that part. And then we have the SoulLoader part. SoulLoader is a library that was also created by Facebook, and they use it to load native libraries, native as in C++ libraries. Because the Facebook core is written in C++, and they also use some third-party C++ libraries, again, we have a dependency because the core is initialized during that stage. So this library is loading C++ files with the SO extension, that's why the name, and it's loading those files in memory. So we need to complete that in order to start React Native. So you can see that we have two dependencies here. One is with our native startup process, the first one, and the other one is with the SoulLoader. But that's still not too bad, because if we do initialization on the background, we can still display the native screen, and we can initialize React Native on the background. And so by the moment we get to a React Native screen, then React Native probably is already initialized, so the user won't notice anything. But look at this case. So in this case, we are initializing our app in a React Native screen. And because React Native is still not ready, we have to display this white loading screen, which doesn't look really good. So the moment or the time the user spent on this white screen is what we call React Native startup delta time. And this is why I said that this is our most important metric. We want to get this as close to 0 as possible, or even better if we can get it to negative value. That would mean that by the moment the splash disappears, React Native is already initialized, and we can show our screen straight away. So yeah, we saw that we have two dependencies, one with our native process and the other one with the sol loader. But what about the sol loader itself? This is just loading a bunch of C++ libraries that has nothing to do with the rest of React Native, or have nothing to do with our native startup process. So what if we do this? What if we split that process, we break it into two parts, and we do the sol loader as soon as we start the app at the same time? And then probably, by the moment we hit the red line, because we have already done the sol loader, we can start initializing React Native. And we could possibly achieve that negative startup delta time that we want to achieve. So yeah, let's see how we can get this, or how we got this in our app. So this is part of our initialization process, native initialization. So we have this class that we call app launch interactor, and it's basically, this orchestrates the whole native app initialization. So everything that's happening in the splash, behind the splash screen, is happening here. And we have it divided in 3 sequential stages. The first one is start process, and this initializes a bunch of really essential components. And we have a series of gateways, and these gateways basically are in charge of initializing different parts of the app. Then we have the next stage is update configuration, and then we have the last stage, which is startup. And because, as I told you before, React Native depends on those native components being initialized first, we are doing the start React Native in this last stage. So the thing is that we were doing the sol loader inside this gateway. So we were doing sol loader part, and then as soon as that finished, we were starting React Native. So basically, we were laying everything to the last stage of our native startup. So we figured that we could break it down into 2 stages, and we could create a sol loader gateway and move it to the first part, to the start process. And so we did. Now sol loader is done in here. So by the moment we get to the last stage, that's already completed, and we can start initializing React Native straight away. And by doing that, we were able to basically achieve this. Now our React Native startup delta time is negative, and it means that React Native is not slower than native in the initialization, and basically that means that we can start our app in a React Native screen. We are not paying any penalty for using React Native. So yeah, enough about performance. Let's move on to the next topic, which is native modules. So I mentioned these a few times before, so let's see what they actually are. A native module is native code that can be used from the React Native side. And what do we use them for? We use them when we need to access APIs that are only available on the native platform. So for example, let's say that a new Android version comes out and has super new APIs, and we don't still have the implementation on the JavaScript side. So in that case, we need to create a native module and expose that native code or native APIs via a native module to the JavaScript side. Another usage is reusing existing native code, and this is our most common usage because Skyscanner app was originally only native. And then we added React Native on top of that. So it made sense, instead of rewriting the whole thing in JavaScript, to make use of the business code logic that was already present on the native side. So we have lots of native modules where we expose different core parts of our app. The core is basically on the native side. And then the last one is when we need to write some high performance or multi-threaded code, JavaScript, it's quite limited in that sense. So when we really want to do some high performance things, we need to do it on the native side and then create a native module to use it from the JavaScript side. So in our app we have, I think, approximately 24 native modules. We keep on adding more when we need them because, as I said, all the core, the business logic is on the native side, so we need to add more. So let's see just one example in a feature of how we are using native modules. This is just one of the features. This is the hotel details screen, and well, the feature we are centering on here is the map. We are displaying some points of interest around the hotel. And the API, this is the only JavaScript code that I'm going to show in this presentation. You can see that we have defined HTTP neural map module, and we have this function that receives latitude, longitude, and number of places that we want to display in a map. And then that's it. Then we just call the native module by its name. So from the JavaScript side, we can make use of this function. But the implementation is not in JavaScript. If we go to the native side, this is where the implementation actually is. You will see that here is where we define the module name that we were calling from the JavaScript side. And the way we can export that or make it visible to the JavaScript world is by extending this class. This is also a class part of React Native core. So then we override this function. We just say React class, which is what we have defined there, and by doing this, we register to the JavaScript side a new native module, so it can be found. And then with this annotation that we have at the top, React method, we implement the method that we defined on the JavaScript side. So you see it's the same: latitude, longitude, and number of places. And here we are using, again, RxJava to fetch the list of places from some backend, and we need to do some data transformation. That's why we have all of this nested code here, because we need to transform the data in a proper format to send it back to React Native. But you can see that the implementation is all on the native side, and 90% of the code of this is basically in Android. So again, native modules is like 95% of the code that you will write for native modules are on the native side. And if you have a big app and you're doing high performance or you're doing complex stuff, you will need to write native modules. So a few more examples. One of them is app navigation. In our case, the navigation framework is on the native side. So that's because we, as I said before, we already had native app, only native app, and all of our navigation was happening on the native side. And also, by doing this, we centralize the navigation logic in just one point of the app. So that means that we can navigate to all the screens in our app seamlessly, no matter if they are React Native or native screens. Another example is when we want to introduce end-to-end testing support for Android with Detox. So Detox is a library that is used for end-to-end testing and is written on top of Espresso. So for those of you who are Android developers, you might know Espresso is the official Android UI testing framework. So because some things were not working out of the box for us, we needed to tweak their native code. And again, we needed to write some Android native code, espresso code in here to make it work. And then upgrading React Native. This is usually not a happy task, and this is one of those tasks that you want to be assigned to. Usually, if you're lucky, it only breaks on the JavaScript side, but most of the cases it also breaks on the native side. So you need to you need some native expertise to help you with when upgrading React Native. So, for example, when we upgraded to React Native 58. They basically, all the constants that we were using to create the metrics that I showed you before, they stopped working. And that was broken on the native side. So we needed to create a PR in Facebook repository, or then create a fork and use it from there. All of that was native code that we needed to write to fix a React Native upgrade. So yeah, you can see that there are lots of examples. I could keep naming a few more, but we don't want to be here forever. So to recap, let's see, why do React Native teams need Android devs then? Or native? This could be also applied to iOS. One of the reasons is implementing React Native performance metrics. We saw that. If we want to get the best React Native performance, there's some tweaks that you can do on the JavaScript side, but if you really want to improve the performance, you have to go to the core, and the core is all native. So that is where you can gain a lot of performance. And then all the reasons we saw for using native modules, like accessing APIs or third-party libraries, or platform features that are only available on the native side, or writing high performance code, or reusing existing native code. And then this last one is having the best code quality and delivery speed. But what I mean by this is, yeah, if you have only JavaScript developers in your team, and you need to write some native code, surely they can do it. They can, like, all of us can Google, all of us can use Stack Overflow, but if you ask me, will they do it as quick as a native developer, or will they do it with the same quality as a native developer? Well, probably not. It will be the same case for me if I try to write some JavaScript code, because I don't have the expertise, I don't have the background. So this helped us a lot when we needed to, in our team, we needed to come up with some React Native features that required both of the backgrounds. So having this diversity of background in the team was really helpful. So yeah, you can see that there are a few things that require native expertise. And don't get me wrong, you can do pretty cool stuff with React Native without ever touching the React Native side, the native side. But I do think that React Native teams could use some help from native developers if they want to make the most of this framework. And yeah, this is what I have for today. Thank you very much. Happy to take questions if there's any.
Thank you very much, Leandro. We have some questions as well. So, how hard or easy is to synchronize with iOS team while working on the new cross-platform module?
Okay, so basically this depends a lot on the structure of the team. In our team, we are 5 people, and we have 3 JavaScript developers, 1 iOS and 1 Android. So it's really easy for us to synchronize, because basically I literally sit next to iOS developer, and we work together. When we need to write a new native module, we work together on that. So we define the API, we define the interface together, we decide what's the best approach to to come up with the native module. So I think it all comes down to the team structure. Now, if you need to work with some other team, yeah, you need basically like it's the same with if you work with features. You need to find a way to properly synchronize. I hope this answers the question.
I saw some hand up. Is there anybody in the audience? Yeah? Okay, so just a minute.
Actually, I wanted to ask the single question in there, but I will just add one additional question to this one. What is the ratio between native and React Native developers in the Android app? And I would like to ask the additional question, what is the ratio between the native and React Native code within the Android app repository?
Okay. So I would say developers and code is almost the same ratio. I would say 25% is almost the ratio in code, and I would say the same in developers. We have 25% JavaScript or React developers, and then the other majority is native developers. So it's pretty much the same number.
Okay. Just moving slowly to the splash screen process, prolong the splash screen.
Good question. No, actually no, because solo loader happens in background thread. So yeah, this is a really good question, because when we are trying to improve React Native startup time, we want to make sure that we are not degrading the native startup time. So everything that we do, every change that we do, we measure that we are not degrading. We have both metrics. We have the native startup time and we have the React Native startup time. And when we change something in React Native, we measure that we are not degrading the native side. But yeah, no, solo that doesn't affect that because it happens in separate threads. So it's not blocking any of the native startup process.
Okay, and one last really cheeky question. Why to have React Native developers at all?
This is a really good question as well. So I guess, again, it all comes down to what works for you. If it doesn't work, then yeah, you can do it natively. In our case, I think it started like an experiment. They basically, this is the same case that in many companies, they wanted to enable React developers or JavaScript developers to contribute to the native code. And the thing is that it worked out very well. All of our hotels is all React Native, and all of our direct booking, which is the place where we do the actual transaction, is working with React Native, and it's working really well, and it allowed us to ship really fast. So I would say it all comes down to whether it works for you or not. In our case, that's my answer. I would say yeah, that's the reason why we have React Native developers, because it has enabled us to ship faster, and it has enabled us to make use of our React developers that they were doing. We had so many things to do, and we didn't have enough native developers to do it.
We have another question from the audience.
Yeah, I still would like to ask you about the solo loader and about the transfer to the splashing process, let's say. Do you have some article or some open source stuff about it, or do you know any other companies or other teams which use this approach? Because this is really interesting, and I would like to see how to use it.
I think, no, I don't have any article written about that. So basically, normally they start the solo loader in the application on start. And this depends on how you structure your native initialization process. So if you don't have any native modules, for example, in our app, you don't have this problem, because you don't have the native modules dependencies with your native code. So basically you can start React Native at the same time. But in our case, we needed to initialize that, and that means that we could make use of that time and put the solo loader there. So it depends on your specific use case, but I didn't see anyone else, I haven't seen anyone else talking about the solo loader. I think everyone just goes to the default, which is initializing it in the application. But feel free to reach out and then we can talk about your specific use case if you want.
Okay, another question? I will go ahead for the questions. I will distribute the sweets afterwards.
Looking forward for the sweets. Thank you. I get another question. What was the biggest challenge you encountered when it comes to the orchestration of the native and React native code within the same repo?
Working on the same repo, it's, I think, one of the main problems is the build time, because that means that all the native developers get annoyed because they have to wait now for the React Native bundle to be built. Otherwise, when you try to access a React Native stream and let's say you're working as a native developer, and you want to test your flow, which happens to be transitioning between native, React Native, and native. If you don't build React Native, it will crash in the middle. So native developers now need to wait for React Native, and that's quite annoying for only native developers, because they feel like, why should I wait for this that I'm not touching that code? So that's one of the main challenges when working with monorepo. I think that you should try to work on improving that build time and trying to make it as easy as possible. Like we had tons of scripts that take care of everything, so they installed all the libraries that we use to build React Native. They would do everything for you, so you don't have to take care of it. Because at the beginning it was failing because, I don't know, some library, some node package was not available, and that was so annoying. That's one of the things. And the other thing is, I would say, about working brownfield app or hybrid app is synchronizing the native side with the JavaScript side using native modules, and especially the hardest one is navigation. When you want to navigate and you need to pass parameters from native screen to React Native or React Native to native, then you realize that are use cases that break your navigation implementation. So you really need to iterate and take care of cases that you haven't thought of before. So I'd say that the most challenging part is when it comes to architecture is navigation. And when it comes to infrastructure is the build process.
Okay, thank you. And if I make one more, what would be your recommendations when it comes to overcome the commonly problematic relations between native and React Native developers?
Sorry, could I get that question again?
In general, I would say that we can observe, let's say, problematic relations between native and React Native developers when they are contributing together. So, what would be your recommendations based on your experiences in Skyscanner to overcome these?
So, I think you need to. Our team is the React Native infrastructure team, so it's basically taking care of that. You need to make their lives as painless as possible. I will say that we are successful if no one is talking about us, because it means that we are invisible. They mean that they don't have any problems. So again, you need to build tooling, you need to automate as much as possible, and then when you need to change something because sometimes that will require some effort from their side, you really need to communicate the value. What is the value of doing this work? Because people are gonna say, this has nothing to do with my work. Why should I do this? So we are working on the same company, right? And we are working for the same goals. So you need to communicate a clear value. What's the value behind it? What are we all going to win by doing this. You will have some resistance, always, because people don't like being put off their normal workflow, and it's kind of annoying for people. But I think that if you communicate your value and it has a real strong value, that's easier because they all understand why they need to do it. But yeah, mostly try to make their lives as easier as possible. Try to be invisible as much as you can.
Okay, thank you very much.
Thank you as well. Do we have some other questions? Okay, so probably thank you, Leandro, for a great talk.
Thank you.